Hi everybody, today we are going to do a problem on solubility. So for our problem, it first tells us that vitamins are categorized as either fat-soluble or water-soluble. Water-soluble vitamins dissolve in body fluids and are easily eliminated in the urine. So there is little danger of overconsumption. Fat-soluble vitamins, on the other hand, can accumulate in the body's fatty deposits. Overconsumption of a fat-soluble vitamin can be dangerous to your health. And it wants us to examine the structure of each vitamin shown here and classify it as either fat-soluble or water-soluble. So first, what do we know about solubility? Well, we know that as a rule of thumb, we were given that like dissolves like, right? And we were also given or told that the more polar a molecule is, the more soluble it will be. And in reference to this problem, the more water soluble it will be, because we're given fat or water soluble. So this statement right here is gonna help us a lot determining whether it's water or a fat soluble vitamin. First, we're going to start off with vitamin C, and we're going to look at this molecule and determine if these bonds are going to make it fat-soluble or water-soluble vitamin, whether it's polar enough. So we see here that there's 4 hydrogen bonds, and those hydrogen bonds are highly polar. And because they're highly polar, they'll make this molecule a polar molecule. Just to go over, these CH bonds are nearly nonpolar, and these CC bonds are not a nonpolar bond. So because they don't really factor into this, because of that OH bonding will allow the hydrogen bonding with water, making this a water-soluble molecule and vitamin. Okay, next we have vitamin K3, and in this one we see that we have these CO bonds here, and that they are polar. However, we also see these CH bonds and these CC bonds. And we know that these CH bonds are nearly nonpolar, and the CC bonds are nonpolar bonds. So because of the overwhelming nonpolar, the bond dipoles will oppose and largely cancel each other, making this a fat-soluble vitamin, even though those CO bonds are polar. Next we have vitamin A, and in vitamin A we notice that over down here is our OH polar bond, the only one though. And we also see that all of this CH bonds and CC bonds are nearly nonpolar, and our nonpolar bonds have a major impact on this molecule, and so it makes it a nonpolar molecule, even though we have this OH bond over here that makes it slightly polar, but does not impact it enough because it is the only one. Therefore, this vitamin will be considered a fat-soluble vitamin. Okay. Lastly, we have our vitamin B5, and in this vitamin B5, we already noticed that we have these 3 OH bonds, and from our previous examples, we saw that the OH bond is a highly polar bonding, and it's pretty strong, making the molecule a polar bond. And it doesn't help, or it also helps with this NH bond here, making this a highly polar molecule, and allowing it to hydrogen bond with water. Because all these aren't really strong enough for this molecule to make it nonpolar, classifying this as a water-soluble vitamin. Okay, thank you.